Hello friends, welcome to my channel. Let's have a look at problem 2397, maximum rows covered by columns. So in this video, we're going to share a sort of brute force solution to this problem. So we are going to select a fixed number of columns specified by the problem and then check rows consisting of all zeros. First, I'll read through the statement of the problem, and then we'll share a very short analysis and then share a very short code. So first, let's look at the statement. So we are given a zero-indexed m by n binary matrix called mat and an integer called columns, so which denotes the number of columns we must choose. A row is covered by a set of columns if each cell in the row that has a value of 1 also lies in one of the columns of the chosen set. So we are required to return the maximum number of rows that can be covered by a set of columns. So here are two examples. So example 2 is sort of trivial because there is only one column. So let's look at the first example. So the first example is a 4 by 3 matrix. So the columns we can choose is the number of columns we can choose is 2. So if we choose the first column index and the third column index corresponding to index 0 and index 2, so then if we change this ones to be 0 and this one to be 0, so we're going to have this row all consisting of zeros, and this row all consisting of zeros, and this row all consisting of zeros. So the output is 3. So with that said, so let's look at the constraints or additional assumptions for this problem. So first, the number of rows and number of columns is bounded below by 1 and bounded above by 12. So 12 is not a large number. So secondly, so the matrix Ij is binary, and then the last one actually is restrict the number of columns we can choose. This number is less than or equal to n, so that's as it should be. So for this problem, actually this problem can be very tricky. So if we want to write the optimal solution, so in this video, so we are going to share a method, sort of brute force. So we are going to select the fixed number of columns, and we can change the corresponding column index, column indices positions to be 0 in the air. So then we count how many rows consisting of all zeros after these operations. So here the consideration is the following. So due to the problem assumption or size, so we could find all the combinations. In other words, we choose the column out of n, where n is the number of columns in the given matrix. And then we count, after changing the corresponding column indices element to be 0, how many rows are consisting of only zeros. Then we just make comparisons according to different valid choice or combinations. So in our solution, we shall write a count hyperfunction, so with early stopping. So lastly, let's comment or make an extension. So this way of solution is sort of brute force, as we specified at the very beginning. So we could think of a bit mask. So bit mask actually is essentially the same thing as here. So basically we need to do traversal or make all possible choices. Or we can write a solution in a recursive format. So the latter actually is good to try. So if we think deeper, actually this problem logic can be tricky and can be complex. So with that said, let's look at the solution we are going to share. So first, I'm going to make some preparations. So for this, I'm going to track the number of rows and number of columns in this problem. So the mat and the length of mat 0. So m is the number of rows and n is the number of columns. So with that said, so I'm also going to fix all the possible combinations. In other words, we want to choose this number of index indices out of n indices, right? So we can do it by just calling a function directly, or we can write a recursive function to do it by ourselves. But for the code structure, I'm going to directly use the iter tools. So this combination, right? Combinations. So we're going to put iterable. So let's call it range n. So this, you can understand it as a list or just an iterable. So consisting of n elements. So here, these n elements are the indices from 0 up to n minus 1. And then what we are going to choose also is this amount, so columns. This is given by the argument in the problem. So this indices actually is an iterable. So this iterable contains this number of elements as it should. So we choose n, from n we choose this number. So this is actually bounded above by c. So at most we have 12, and when it's in the middle, this is the largest possible. So this is the bound for the number of indices in this problem. So with that said, I'm going to define a hyperfunction. So for each of the tuple in indices or collection of indices, so I'm going to change the corresponding elements with column index in the tuple, and then we count how many rows are all consisting of zeros. So and then let's first do this. So define 0 rows. So the input will be the mat, the original matrix, and a array. So the array, you can understand it as a list or a tuple or iterable. It does not matter. So first, I'm going to initialize a result to be 0. And then the overall idea is that, so this is a collection of indices. So that's the column index is in the array. So we're going to change the elements corresponding to the column indices to be 0. And then if after the change, so the rows, we are going to count the number of rows that are all zeros. So we actually do not need to do it we can do it just as we stated. So we can do it in the air. So because we just need to count the number of rows consisting zeros after the operation. So we can do something like this for row in matrix. So what we're going to do is that we initialize a flag variable. So originally it's called it 1, and then we are going to check if the indices in the current row corresponding to 1 are all included in the indices from this array. If so, actually we can make this row all zeros after we do the change, right? So this is actually routine. So this is for I in range m. So what we're going to do is that, so we check if row I so equals 1, and then we're going to check if I not in array. So it means that even we do the change, so this row cannot be covered. So we're going to set this flag to be 0 at break, right? And then afterwards, so after the iteration, so on each of the iterations, so we're going to update the result by adding the flag. So if the flag is 0, so it does not count. If flag is 1, we count this row. So then we're going to return the result state. So that's the function. Actually, this is also the main work. So the main work of this problem comes from this part and this hyperfunction. So next, we just need to do comparisons, find the maximum possible rows we can cover, specific to a special combination. So for this, we can initialize a result variable and then iterate over the indices, right? So for array in this iterator, so in indices, then what we're going to do is that we're going to update the result to be the maximum of the previous state. And so if we use this set of indices, we see how many rows we can cover. So it's 0 rows as a matrix, the same matrix, and the array. So once we finish this loop, so we're going to return the result state. So this actually consists of a full solution to this problem. Let's do a special case check first. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I would say for this problem, so the V present here is sort of brute force again. So it's good to try to generalize this problem and make some further study. So with that said, I guess that's about it for this problem for now. Thank you very much.